Hello friends, welcome to engineering tutorial. So here is another question on full wave rectifier. So the question is that here there are two circuit diagrams. One is for a center tap rectifier, this first one, and then we have the bridge rectifier. Both of them have the same supply voltage, same frequency and the same turns ratio, same load resistance, everything, but this is center tap, this is bridge type full wave rectifier. And we have been asked first to find the DC output voltage in each of the two cases, and in the second one, which is a bit interesting, for the same DC output, for the same DC output we have to design the circuit so that it gives the same DC output, and we have to determine the peak inverse voltage for each case. So we have to design the rectifiers in such a way, both center tap and bridge type, such that it gives the same DC output, and we have to determine the peak inverse voltage. And it has been asked to assume that the diodes are ideal, that is no cut-in voltage, no forward resistance. Okay, so first for this center tap full wave rectifier. Center tapped full wave rectifier. The turns ratio is NP by NS, which is 5/1. It is related with the primary winding voltage and the secondary winding voltage. Same goes for the RMS and maximum values also. Here we'll be using the RMS value because this 230 volt 50 Hz, this is the RMS value of the AC supply. So here that is equal to the primary winding RMS voltage for the center tap rectifier for the first circuit diagram is 230 RMS value. The RMS value of the secondary voltage is unknown, so we have to determine that. That is equal to 5/1. That implies V secondary RMS is equal to 230 by 5. 230 by 5, which is equal to 46 volt. This is the RMS value. Maximum value we know for sinusoidal supply, Vrms is equal to Vmax by root 2, isn't it? Max by root 2. So the maximum value of the secondary voltage, winding voltage, is equal to 46 root 2, which is equal to 65 volt. So here I will be copying this diagram to make you understand something. This one here. So here what it means is that the secondary maximum voltage, it means that from here to here, this is 65 volt, the maximum value. 65 volt, Vs max. Now you know that in center tap rectifier, this maximum secondary winding voltage gets divided equally, in between the center tap point and the other end of the secondary. This equally means 32.5 volt, 32.5 volt. This 32.5 volt is the maximum value of the voltage, 32.5 volt. You can also call it the maximum value of the center tapped winding, the secondary winding voltage, which is 32.5 volt, which is subjected to the diode, the two diodes. Now we have been asked to find the output DC voltage which appears across the load resistance. So here the DC value is equal to the formula 2 Vmax by pi. This is only applicable when the diodes are ideal, that is forward resistance is equal to 0 ohm, because in this case there is no voltage drop, across the diodes. Okay, this. So here similarly V out DC, the DC value of the output voltage is equal to 2 VCT max, that is the center tapped maximum voltage, divided by pi, which is equal to 2 into 32.5 by pi, and it is coming around 20.7 volt. That is the output DC voltage. Okay, the DC value of the output voltage, this. Now if you want to determine the DC current, okay, or the load current, the same thing. Okay, the load current or the ILDC is the same thing, which is equal to V output DC by RL, which is equal to 20.7 volt by RL, which is equal to how much? 100 ohm, I think. 100 ohm, yes, 100 ohm. 100 ohm, which is equal to 0.207 ampere. This. Okay, this is for center tapped full wave rectifier. Then for the bridge type rectifier, so let us copy this circuit diagram also. So here also everything is the same. The supply voltage is same, 230 volt, 50 hertz. Then the turns ratio is the same. So it means here also the maximum value of the secondary winding voltage will be the same, that is 46 root 2, which is equal to 65 volt. But here what is the difference? Okay, what is the difference, the crucial difference between center tapped and bridge type full wave rectifier is that here this entire 65 volt is the maximum voltage which is subjected to the bridge type rectifier circuit. This here, okay, this here is 65 volt, that is the maximum secondary winding voltage, and here also this entire voltage is subjected to the diode circuit. But what was the difference in the center tap full wave rectifier? From the center tap point, that maximum secondary winding voltage or the secondary winding voltage, it was divided equally, but here the entire 65 volt is subjected to it. So here in this case, for this is the bridge type full wave rectifier, okay, the bridge type full wave rectifier, the center tapped maximum voltage is equal to 65 volt. Here it was 65 by 2, which is equal to 32.5 volt. Okay, so here in this case the output DC, which is simply same formula, 2 VCT max by pi. Why? Because forward resistance is equal to 0 ohm, so no diode voltage drop. So that will be 2 into 65 volt by pi, and that is equal to, it is coming around 41.4 volt. Okay, and if you want to determine the value of the DC value of the load current, then it will be V output DC by RL, which is equal to 41.4 volt by 100 ohm, same load resistance, everything is the same, so it is 0.414 ampere. Yes. Now the first bit is completed. Now we have the second bit, that is for the same DC output. Okay, for the same DC output we have to determine the peak inverse voltage. Okay, so here let us first copy this both, okay, both of them, both the circuit diagrams. So let us consider both of these circuits separately. Okay, so here it has been asked that the output, the DC output obtained across the load, okay, the DC output obtained across the load, it should be the same for both center tapped and bridge type rectifier circuit. Now we calculated that for both the circuits the output DC, okay, the DC output is given by 2V max by pi, 2V max by pi. Okay, so here for bridge type it is not CT max, it is only for center type, it is simply V max. Okay, by mistake I have written here CT max. Okay, it is simply maximum winding, okay, maximum voltage across the winding. For center type it's only maximum. Okay, so don't get confused. Okay, so it is simply V max, okay, 65 volt. So the crucial difference is that 2 V max by pi, that is the output DC voltage. V max is the maximum voltage to which the diode is subjected. Now let us say for the center tapped full wave rectifier we keep the same conditions. Okay, 5:1 turns ratio, 230 volt, 50 hertz, 100 ohm, everything is the same. So when everything is the same, the output voltage which will obtain, the DC value of the output voltage, it will be equal to 20.7 volt. Okay, 20.7 volt, when V max will be equal to 32.5. okay, so this expression 2V max by pi, it is the same for both center tapped and bridge type full wave rectifier. So the output DC will be the same when for both of these circuits the maximum voltage to which the diode is subjected is 32.5 volt. Okay, because here for bridge type rectifier the V max is 65 volt, that is why the output voltage is different. Here in this case the V max is 65 volt, this for bridge type rectifier circuit. In center type it got divided equally, that's why it is 32.5 volt. So we have to design the circuit in such a way that for both of them the maximum value of the voltage which is subjected to the diodes is 32.5. So here we have to manipulate the turns ratio. Okay, we have to manipulate the turns ratio, NP by NS, primary winding to the secondary winding. So how we can do that? Now we know that for this okay, for this bridge type rectifier circuit, this RMS value, this is the NP by NS is equal to VP by Vs. It can be RMS or maximum value, Vp max by Vs max. So directly let us take the maximum value. Here it is 230 RMS, so the maximum value is 230 root 2, and this is the secondary maximum voltage which we want is 32.5 volt. Why? Because in bridge type rectifier voltage circuit, this entire secondary maximum voltage is appearing across this. So here if it is 32.5 we want, then the secondary maximum voltage should also be 32.5. Okay, here also it should be 32.5 volt. In bridge type rectifier circuit, this entire voltage, secondary maximum voltage, appears across the diode. But in center tap it gets divided, but we want the maximum voltage to be 32.5. Only then both the outputs will be the same. So in that case the turns ratio will be NP by NS, which is equal to 230 root 2. It is coming 230 root 2. It is coming around 325.2. So rounding it off, it is 325, and here it is 32.5. So it is 10 or 10:1, the turns ratio. So here the turns ratio is 10:1. So if we change the turns ratio of the bridge type rectifier to 10:1, in that case we will get the maximum voltage appearing across the diode as 32.5. So in that case, for both center tap full wave rectifier and bridge type full wave rectifier, the maximum voltage will be the same, and the output DC will be equal to 2V max by pi, which is equal to 2 into 32.5 by pi, which is equal to, it is coming 20.7 volt. This the output DC, 20.7 volt. Now for the peak inverse voltage, okay, PIV, we know that for center tap full wave rectifier, okay, for center tap full wave rectifier, the peak inverse voltage is equal to twice of the maximum voltage, is equal to 2 into 32.5 volt, which is equal to 65 volt. But for bridge type rectifier circuit, the peak inverse voltage is equal to the maximum voltage, which is equal to 32.5 volt. So here another important thing is that for bridge type rectifier, even though we are getting the same output DC voltage, the peak inverse voltage is less as compared to center type full wave rectifier. Okay, for center type it is twice that. For the same DC output we are getting twice peak inverse voltage, but for bridge type rectifier it is half that of center type rectifier. Here it is 65, here it is 32.5. Okay, so this is the thing. So the only way we can manipulate both the circuits for the same DC output voltage is by manipulating the turns ratio, Okay, this. So here for bridge type rectifier circuit, we increase the number of turns of the primary winding. Why? Because of the simple reason, in center tap the maximum secondary voltage, it gets divided equally from the center tap point, and in bridge type rectifier the entire secondary voltage appears across this. So we had to increase the turns ratio of the bridge type rectifier so that we can get the same maximum voltage, and when we get the same maximum voltage we can get the same output DC voltage for both the full wave rectifier circuits. Okay.